Preparing for the AP Stats exam. Flashcards. Interpret standard deviation. Standard deviation measures spread by giving the typical or average distance that the observations in context are away from their contextual mean. Outlier rule. The upper bound is quartile 3 plus 1.5 times the interquartile range. The lower bound is quartile 1 minus 1.5 times the interquartile range. The interquartile range is quartile 3 minus quartile 1. Linear transformations. Adding A to every member of a data set adds A to the measures of position, but does not change the measures of spread or the shape. Multiplying every member of a data set by B multiplies the measures of position by B and multiplies most measures of the spread by the absolute value of B, but does not change the shape. Describe the distribution or compare the distributions. SOCs. Shape, outliers, center, spread. Only discuss outliers if there are obviously outliers present. Be sure to address SOCs in context. If it says compare, you must use comparison phrases like is greater than or is less than for center and spread. SOCs. Shape. Skewed left, mean is less than median. Skewed right, mean is greater than median. Fairly symmetric, mean is about the same as median. Outliers. Discuss them if there are obvious ones. Center, mean or median. Spread. Range, IQR, or standard deviation. Note. Also be on the lookout for gaps, clusters, or other unusual features of the data set. Make observations. Using normal CDF and inverse norm calculator tips. Normal CDF takes the min, the max, the mean, the standard deviation. Inverse norm takes the area to the left as a decimal, the mean, and the standard deviation. Interpret a z-score. Z is the fraction value minus mean divided by standard deviation. A z-score describes how many standard deviations a value or statistic, x, x bar, p hat, etc., falls away from the mean of the distribution and in what direction. The further the z-score is away from 0, the more surprising the value of the statistic is. What is an outlier? When given one variable data, an outlier is any value that falls more than 1.5 times IQR above Q3 or below Q1. A regression outlier is any value that falls outside the pattern of the rest of the data. Interpret least squares regression line slope B. For every 1 unit change in the x variable in context, the y variable in context is predicted to increase or decrease by blank units in context. Interpret least squares regression line y-intercept A. When the x variable in context is 0, the y variable in context is estimated to be blank. Put the value there. Interpret r-square. Blank percent of the variation in y in context is accounted for by the least squares regression line of y in context on x in context, or percent of the variation in y in context is accounted for by using the linear regression model with x in context as the explanatory variable. Interpret R. correlation measures the strength and direction of the linear relationship between x and y. R is always between -1 and 1. Close to 0 means very weak. Close to 1 or -1 means stronger. Exactly 1 or -1 is a perfectly straight line. A positive R is a positive correlation. A negative R is a negative correlation. Interpret the least squares regression line, quote, SE sub b. SE sub b measures the standard deviation of the estimated slope for predicting the y variable in context from the x variable in context. SE sub b measures how far the estimated slope will be from the true slope on average. Interpret least squares regression line S. S equals blank is the standard deviation of the residuals. It measures the typical distance between the actual y values in context and their predicted y values in context. Interpret least squares regression line y hat. Y hat is the estimated or predicted y value in context for a given x value in context. Extrapolation. Using a least squares regression line to predict outside the domain of the explanatory variable can lead to ridiculous conclusions if the current linear trend does not continue. Interpreting a residual plot. 1. Is there a curved pattern? If so, a linear model may not be appropriate. 2. Are the residuals small in size? If so, predictions using the linear model will be fairly precise. 3. Is there increasing or decreasing spread? If so, predictions for larger or smaller values of x will be more variable. What is a residual? Residual, y minus y hat. A residual measures the difference between the actual observed y value in a scatter plot and the y value that is predicted by the least squares regression line using its corresponding x value. In the calculator, you might do list 3 equals list 2 minus y1 sub list 1. Sampling techniques. Number 1, SRS. Number the entire population. Draw numbers from a hat. Every set of n individuals has an equal chance of selection. 2. Stratified. Split the population into homogeneous groups. Select an SRS from each group. 3. Cluster. Split the population into heterogeneous groups called clusters and randomly select whole clusters for the sample. For example, choosing a carton of eggs actually chooses a cluster or group of 12 eggs. Number 4. Census. An attempt to reach the entire population. 5. Convenience. Selects individuals easiest to reach. 6. Voluntary response. People choose themselves by responding to a general appeal. Experimental designs. 1. CRD, completely randomized design. All experimental units are allocated at random among all treatments. 2. RBD, randomized block design. Experimental units are put into homogeneous blocks. The random assignment of the units to the treatments is carried out separately within each block. 3. Matched pairs. A form of blocking in which each subject receives both treatments in a random order, or the subjects are matched in pairs as closely as possible, and one subject in each pair receives each treatment determined at random. Goal of blocking. Benefit of blocking. The goal of blocking is to create groups of homogeneous experimental units. The benefit of blocking is the reduction of the effect of variation within the experimental units. Advantage of using a stratified random sample over an SRS. Stratified random sampling guarantees that each of the strata will be represented. When strata are chosen properly, a stratified random sample will produce better, less variable, more precise information than an SRS of the same size. Experiment or observational study. A study is an experiment only if the researchers impose a treatment upon the experimental units. In an observational study, researchers make no attempt to influence the results. Does blank cause blank? Association is not causation. An observed association, no matter how strong, is not evidence of causation. Only a well-designed, controlled experiment can lead to conclusions of cause and effect. SRS. An SRS, a simple random sample, is a sample taken in such a way that every set of n individuals has an equal chance to be the sample actually selected. Why use a control group? A control group gives the researchers a comparison group to be used to evaluate the effectiveness of the treatments. In context, gauge the effect of the treatment compared to no treatment at all. Complementary events. Two mutually exclusive events whose union is the sample space. A complement. Example, rain or no rain. Draw at least one heart, draw no hearts. The probability of at least one. The probability of at least one is equal to 1 minus the probability of none. Two events are independent if the probability of B is equal to the probability of B given A, or the probability of B is equal to the probability of B given A complement. Meaning, knowing that event A has occurred or not occurred doesn't change the probability that event B occurs. Interpreting probability. The probability of any outcome of a random phenomenon is the proportion of times the outcome would occur in a very long series of repetitions. Probability is a long-term relative frequency. Interpreting expected value, or mean. The mean or expected value of a random variable is the long-run average outcome of a random phenomenon carried out a very large number of times. Mean and standard deviation of a discrete random variable. This is on the formula sheet. The mean is the sum of x sub I times p sub I. The standard deviation is the square root of the sum of x sub I minus mu sub x times p sub I. The mean and standard deviation of a difference of two random variables. The mean of two random variables difference is the difference of the means. The standard deviation of the difference is the square root of 1 of the standard deviations squared plus the other standard deviation squared. The standard deviation of a difference of two dependent random variables cannot be determined because it depends on how strongly they are correlated. Mean and standard deviation of a sum of two random variables. The mean of the sum of two random variables is the sum of the means. The standard deviation of the sum of two independent random variables is the square root of the sum of the squares of the standard deviations. The standard deviation of the sum of two dependent random variables cannot be determined because it depends on how strongly they are correlated. Binomial distribution. Conditions. Bins. Binary. The trials can be classified as success or failure. Independent. Trials must be independent. Number. The number of trials must be fixed in advance. Success. The probability of success must be the same for each trial. Geometric distribution. Conditions. Bits. Binary. Trials can be classified as success or failure. Independent. Trials must be independent. Trials. The goal is to count the number of trials until the first success occurs. Success. The probability of success must be the same for each trial. Binomial distribution. Calculator usage. Binomial PDF. Mean and standard deviation of a binomial random variable. Also on the formula sheet. The mean of mu sub x is n times p. The standard deviation, sigma sub x, is the square root of n times p times 1 minus p. Why large samples give more trustworthy results when collected appropriately. When collected appropriately, large samples yield more precise results than small samples because in a large sample, the values of the sample statistic tend to be closer to the true population parameter. The sampling distribution of the sample mean. The central limit theorem. 1. If the population distribution is normal, the sampling distribution will also be normal, with the same mean as the population. Additionally, as n increases, the sampling distribution's standard deviation will decrease. 2. If the population distribution is not normal, the sampling distribution will become more and more normal as n increases. The sampling distribution will have the same mean as the population, and as n increases, the sampling distribution's standard deviation will decrease. Unbiased estimator. The data is collected in such a way that there is no systematic tendency to overestimate or underestimate the true value of the population parameter. The mean of the sampling distribution equals the true value of the parameter being estimated. Bias. The systematic favoring of certain outcomes due to flawed sample selection, poor question wording, undercoverage, non-response, etc. Bias deals with the center of a sampling distribution being off. Explain a p-value. Assuming that the null is true in context, the p-value measures the chance of observing a statistic or difference in statistics in context as large or as larger than the one actually observed. Can we generalize the results to the population of interest? Yes, if a large random sample was taken from the same population we hope to draw conclusions about. Finding the sample size for a given margin of error. For one mean, margin of error is z star times sigma over root n. For one proportion, margin of error is z star times the square root of the fraction p times 1 minus p over n. If an estimation of p is not given, use 0.5 for p. Solve for n. Carrying out a two-sided test from a confidence interval. We do or do not have enough evidence to reject h sub 0 mu equals a number in favor of h sub a, mu does not equal some number at the alpha equals 0.05 level because blank falls outside or inside the 95% confidence interval. The alpha is 1 minus the confidence level. The four-step process for confidence intervals. Number 1, state. What parameter do you want to estimate and at what confidence level? 2, plan. Choose the appropriate inference method. Check conditions. Do. 3. If the conditions are met, perform calculations. 4. Conclude. Interpret your interval in the context of the problem. The four-step process for significance tests. Number 1, state. What hypotheses do you want to test and at what significance level? Define any parameters you use. 2, plan. Choose the appropriate inference method. Check conditions. 3, do. If the conditions are met, perform calculations. Compute the test statistic and find the p-value. 4, conclude. Interpret the result of your test in the context of the problem. Interpreting a confidence interval, not a confidence level. I am certain % confident that the interval from blank to blank captures the true blank. Interpreting a confidence level, the meaning of 95% confident. Intervals produced with this method will capture the true population blank in about 95% of all possible samples of this same size from this same population. Paired t-test, phrasing hints, h sub o and h sub a. Conclusion. Key phrase, mean difference. H sub o. The mu of the difference equals 0. H sub a. The mu of the difference is either less than 0, greater than 0, not equal to 0. Mu sub difference is the mean difference in blank for all blank. We do or do not have enough evidence at the 0.05 level to conclude that the mean difference in blank for all blank is blank. 2 sample t-test, phrasing hints, h sub 0 and h sub a. Conclusion. Key phrase, difference in the means. H sub 0 of mu1 minus mu2 equals 0, or mu sub 1 equals mu sub 2. H of a. Mu1 minus mu2 is less than 0, or greater than 0, or not equal to 0. Mu sub 1 minus mu sub 2 is the difference between the mean blank for all blank and the mean blank for all blank. We do or do not have enough evidence at the 0.05 level to conclude that the difference between the mean blank for all blank and the mean blank for all blank is blank. Type 1 error, Type 2 error, and power. A Type 1 error, rejecting h sub 0 when h sub 0 is actually true. Example, convicting an innocent person. Type 2 error, failing to reject h sub 0 when h sub 0 should be rejected. Example, letting a guilty person go free. Number 3, power. The probability of rejecting h sub 0 when h sub 0 should be rejected, or rejecting correctly. Factors that affect power. Sample size. To increase power, increase sample size. 2. Increase alpha. A 5% test of significance will have a greater chance of rejecting the null than a 1% test. 3. Consider an alternative that is farther away from mu sub 0. Values of mu that are in h sub a but lie close to the hypothesized value are harder to detect than values of mu that are far from mu sub 0. Inference for means. Conditions. Random. Data from a random sample or randomized experiment. Normal. Population distribution is normal or large samples. N sub 1 is greater than or equal to 30, or N sub 1 is greater than or equal to 30, and N sub 2 is greater than or equal to 30. Independent. Independent observations and independent samples or groups. 10% condition if sampling without replacement. Inference for proportions. Conditions. Random. Data from a random sample or randomized experiment. Normal. At least 10 successes and failures in both groups for a 2-sample problem. Independent. Independent observations and independent samples or groups. The 10% condition is sampling without replacement. Types of chi-square tests. Number 1. Goodness of fit. Used to test the distribution of one group or sample as compared to a hypothesized distribution. Number 2. Homogeneity. Used when you have a sample from 2 or more independent populations or 2 or more groups in an experiment. Each individual must be classified based on a single categorical variable. 3. Association or independence. Used when you have a single sample from a single population. Individuals in the sample are classified by 2 categorical variables. Chi-square tests. Degrees of freedom and expected counts. Goodness of fit. Number 1. Degrees of freedom is number of categories minus 1. Expected counts is sample size times hypothesized proportion in each category. 2. Homogeneity or association independence. Degrees of freedom is number of rows minus 1 times number of columns minus 1. Expected counts is row total times column total divided by table total. Inference for counts. Chi-squared test. Conditions. Random. Data come from a random sample or randomized experiment. Large sample size. All expected counts are at least 5. Independent. Independent observations and independent samples or groups. 10% condition if sampling without replacement. Inference for regression. Conditions. Linear. True relationship between the variables is linear. Independent observations. 10% condition if sampling without replacement. Normal. Responses vary normally around the regression line for all x values. Equal variance around the regression line for all x values. Random. Data from a random sample or randomized experiment.
End of line.